some example we will understand those. Now first one, this is example of first law of motion or inertia of law of inertia. Means there are figure of a carom or a desk, and this is could be coins. Okay, so we put coins in row, and when we hit a coin, so this coin strike to last coin, and last coin will be out. So hold these coin, not that one, these coin stay in. So these coins stay in rest, they haven't changed their position or state. Okay, in second example here, this is also same example of inertia. Here this is a cardboard, this is glass, this is coin. We remove the cardboard instantly by hitting or forcing him, and the coin stay in rest and dropped out vertically. In this example, we can see a girl and a boy, they are playing with a bag. Okay, this surface is frictionless, smooth surface. Okay, when two children standing on two different cards play this game or catching the sandbag, the card of each child shows clear movement. This is because of instantaneous reaction of throwing the bag. When the boys throw the bag toward the girl, card of boy move back, action reaction. Similarly, when the girl throw the bag toward the boy, the card of girl move back. The force of action and reaction are equal in magnitude. The mass of a girl is normally less than the mass of body. Therefore, the acceleration produced in the cart of girl will be more than acceleration produced in the cart of the boy. It implies that in a given interval of time, cart of girl will move through a large distance than the cart of boy. Means if the boy threw this bag to girl, so this boy move backward, and if this girl take this sandbag and throw it back, so she will move backward direction, and the distance of traveling of both, so the distance of girl will be larger than the boy due to inertia. I is equal to m into a, sorry, m into r square. Inertia is equal to m into r square. Here you can do this on your home. There, this is a balloon, this is a straw, this is a string, and we tied both ends of this string. We attach the balloon to this straw and leave the mouth open. Then this balloon emit gas in this direction. This air exert a force on a balloon in this direction, action reaction, and then the balloon move in this direction. So the balloon attached with straw, so straw will move in this direction on this string. This is also an example of action reaction. Here you can see this is a tube, this is a tube, this is cork. We are heating it and we filled some liquid here. This is liquid, this is cork, this is tube. We adjust this and we light a lamp here. We heat up. After some time, when this liquid changes in vapor or water change in stream and make some force, applied some force on this cork. So the value of force is equal to F is equal to pressure into area, pressure of liquid. So the vapor applied some pressure on this cork, the value, this is P, and the area of this cork A is equal to F, the force. So if we need, so when we heat up this liquid, it changes in vapor and it applied some force on cork, and after some time the coil blew out. This is the third law of motion, action and reaction. A cork blow out and equal reaction develop on test tube, moving the tube in opposite in the direction. Third law of motion. There are some questions on exercise, very short answer type question. You can read this question by yourself. Stop this, pause this video, then take a screenshot and read all these questions. Question number 1, 2, 3, 4. This is what is inertia, why does the carrier open shut. All the questions. If anyone of you have any problem, then ask on the WhatsApp group. Very short. This is short. Then this is example numerical. You can solve this by yourself if you want. Question number 5, question number 6, question number 7, question number 8, question number 9, question number 10, question number 11. And this is the self-assessment. We will do this self-assessment by himself. Here I have another book, this one, Raju Prakashan. Here something is good, so we take the example and a view on this book. Force. We already we read about force. What is force? Force is the push or pull which can make a body move, stop a moving body, change the direction and speed of moving body. Force cannot be seen, but the effect of force of an object can be seen or felt. As you can see here, two boy, he is pulling and he is pushing. So pulling, pushing, changing of direction, of motion, of or velocity, or stop a moving body or move a stop body is a force. It cannot be seen by eyes, but it can felt. Definition: a force is physical quantity which causes or tends to cause a motion in an object at rest, or change or tends to change the direction of motion of moving object, or change or tends to change the size and shape of an object, or change to change the speed of an object. If you like anything, then you can write down this. Effect of force. A force produces the following effect. It can move or tend to move an object. It can stop or tends to stop an object in motion. It can change or tend. It can stop or tends to stop an object in motion. It can change or tends to change the direction of motion of an object. It can increase or decrease the speed of an object. It can change the shape or size of an object. Force can move or tends to move an object. When a force is applied on a stationary body, it can either move the body or tends to move it. The motion of the body take place in the direction of the applied force. Some example of these are when a football is kicked in is set into motion. A railway locomotive applied force on the railway wagon to set them into motion. A horse applied force on the car to pull it. At time when you push a wall, you can unable to move it. The force applied by you tends to move the wall. Here you can see this ball is coming, strike and move. The ball is going in this direction, but this boy applied a force and the ball goes in this direction. Here the direction are changed. Here the bat hit the ball and the ball goes in motion. Okay, here the ball is coming and he put a hand, so this hand stop the ball. Resultant force. If a single force acting on a body produces the same acceleration as produced by number of force, that single force is called the resultant force of this individual force. Suppose this can be explained by this. Suppose this is a point and there are number of set forces which are applied. Okay, this is F1, this is F2, this is F3, this is F4, this is F5, this is F6 and this is F7. Okay, this is a point. We applied several number of forces and the single, this is same point and the this force, this F represent the acceleration which this force shows, so this force will be called a resultant force. Now if a single force acting on a body produces the same acceleration, as you can see here, a single force acting on a body produces the same acceleration as produced by the number of forces, that single force is called the resultant of this individual force. As you can see in this table, or you can understand by this example. Normal force. Normal force is, suppose this is surface, this is a body. So if this is body is mass m, so gravitational force is equal to m into g. Weight, this is equal to weight w. Okay, and when a body applied a force on this surface, so this surface also applied a force equal to the weight of body but in opposite direction, means in this direction. It can be shows as like this. Here you can see this is normal force. This can be represented by N or R, normal reaction force. Okay, balance and unbalanced force. If a set of force acting on a body produced no acceleration in it, the force are said to be balanced. If we applied a force on a body and it produced no acceleration, mean this is balanced force. If it produces a non-zero acceleration, the body are said to be unbalanced. It produces acceleration, so it is non-balanced force. We already talked about that. Inertia. The tendency of a body to oppose any change in its state of rest or uniform motion is called inertia of body. You can write down this. Galileo observations. Galileo law of inertia. This is the observation, and he found object moving down a smooth inclined plane accelerate. Moving object up a smooth inclined plane retard. When object is falling down on an incline, it will accelerate. When it goes up on an incline, it retard. When moving on a frictionless horizontal plane, move with a constant velocity having neither acceleration nor retardation. When an object is moving on a smooth or frictionless surface, then it will move with uniform velocity, neither acceleration nor retardation. Okay, this is the observation of Galileo. You can see here the ball is coming, then going, then up and stop. At every condition, the ball will stop if this is a smooth surface on same height. It and goes to same height, then stop. We these are you already learn about these. If you want, you can read these all. Take a screenshot and read these all if you want. Here, law of conservation of momentum. This is the samples. Now here we are going to understand recoil of gun. The recoil of gun can be explained. The recoil of a gun can be explained with the help of the law of conservation of momentum. The bullet inside the gun and the gun itself from a system. Thus, the system is gun plus bullet before firing the gun, and the bullet are at rest. Therefore, momentum of system before firing is zero. Velocity is zero, so momentum is zero. When the bullet is fired, it leaves the gun in the forward direction with certain momentum, since no external force act on the system. There are no external force when we fire the gun. When we fire the bullet, there are no external force but the internal force, so there are action and reaction. Since no external force act on the system, so the momentum of the system gun plus bullet must be zero after firing. This is possible only if the gun moves backward with momentum equal to the momentum of bullet. That is why gun recoil or move backward. The velocity with which the gun move backward after firing a bullet is known as recoil velocity. In numerical, we have to find the recoil velocity. So you have to know about what is recoil velocity. Calculate of recoil velocity of a gun. Mass of a bullet is m. Velocity of a bullet after firing is v. Mass of the gun is capital M. This is mass of bullet. This is mass of gun. Velocity of gun after firing. Since the system is at rest before firing, so momentum of the system gun plus bullet before firing is 0. Total momentum of system gun plus bullet after firing is equal to momentum of gun. Since the system is at rest before firing, so momentum of system gun plus stable before firing is equal to 0. Total momentum system gun plus bullet after firing is equal to momentum gun plus momentum of bullet, mv plus m. Now take this like v2. Okay, now put the v2. Now here same v2. Oh, sorry, this is capital V, this is capital V here, this one, and this is small v. So capital M, capital V is equal to minus small m, small v. So capital V is equal to minus m upon m into v. And negative sign shows that the direction of the velocity of gun after firing is opposite the direction of the velocity of the bullet. Rocket proposition, momentum of rocket in the upward direction. The momentum of rocket in the upward direction can also be explained with the help of the law of conservation of momentum. The momentum of rocket before it fired is 0. When the rocket is fired, gases are produced in the combustion chamber and the rocket, due to burning of fluid, these gases come out of the reel of rocket with high speed. Suppose this is a suppose this is a rocket, this is exhaust. Okay, if initial condition p is equal to 0, p1 is equal to 0, initial condition. Okay, final condition, when he leaves gases from his rear or exhaust, so these gases put some force on this rocket and this rocket moves. Here as you can see, the momentum of rocket before it fired is 0. When the rocket is fired, gases are produced in the combustion chamber of the rocket due to burning of fuel. These gas, the direction of these gas come out real of the rocket with high speed. The direction of the motion of the gases coming out the rocket in downward direction. To conserve the momentum of the system, rocket plus gases, the rocket move upward with a momentum equal to the momentum of the gas. The rocket continues to move upward as long as the gases are ejected out the rocket. Initiate balloon lying on the surface of a floor move forward when pierced with a pin. The momentum of the initiate balloon before it is pierced with a pin is 0. When it pierced with a pin, air in it comes out with a speed in backward direction. So conserve the momentum, the balloon move in the forward direction. The balloon goes in forward direction because the gases are going in backward direction. And you can read